Hello and welcome again. Let me recall what we were doing. So last time we had the structure of the key schedule. So basically what we had was 56 bits here, and we divided that 56 bits into two blocks, each one of them of 28 bits, so by half. And to generate all the keys, the 16 keys, what we have to do is apply a transform or transformation to this block that is here. So every transformation is gonna look similar. The inner structure of transformation 1, 2, and all the way through 16 is gonna look very different. The output of every transformation is, of course, is gonna be the subkey. For transformation 1 will be subkey K1 of 48 bits, and for the other ones it's gonna be the same. So the different subkey. Now, what I'm gonna do now is let's look at transformation 1. Because that's pretty much how all the other transformations are gonna work. So transformation 1, let's see the inner structure of that. So this is how transformation 1 or transform 1 is gonna work. The input of that is gonna be the 56 bits here. So let me write that down. So we have here a total of 56 bits, and they are divided into blocks of 28 bits each. That's what the 28 here means. So this Z0, the left hand side of this block is 28 bits, and the right hand side D0 is 28 bits also. So this is the input of the transform 1, this block of 56 bits that you see here. And if you let me scroll up over here, that's exactly what I have here. This is my block. Is gonna be the input of this transform. All right, so what is transform 1 doing to that block? So let me scroll all the way down again. So what it's doing to that block is the following thing. It's gonna act on each block individually. So I'm gonna take the block Z0, which is 28 bits, and it's gonna apply this transformation. This is gonna be called left shift 1. That is it. Let's indicate that by this arrow. Left shift 1 is a left shift of bits, and in this case will be 1 bit, and I will explain that in a second. The same thing is gonna do to the second block. It's gonna do a left shift of 1 bit. That's not gonna change too much here, the blocks, of course, but then it's gonna come into here. So that's what this is the output that this left shift does here. It gives me the left hand side. And the output of this left shift of 1 bit gives me the right hand side over here. Now, this is a new block. It's different from Z0. D0 is a new block. This is the block that you get after shifting to the left half of the block at the left hand side and half of the other block the right hand side. Now, once that's done, that left shifting is done, then this is gonna go to a permutation. This permutation choice 2, and I'll talk about that, what permutation does. And then it's gonna take 56 bits, because this whole block is 56, because it comes from 28 and 28. So it's a 56 block. It comes into the permutation. That permutation, again, what it's gonna do is gonna ignore 8 bits, but it is gonna ignore it through a permutation. So as you can imagine, this here is gonna be also a table. That's going to tell us how to transform this 56 bit into a 48 bit. And that's how the first subkey is going to come out of this transform. Now, the input of the next transform, which is transform, this is transform 1. Then the input of the next one, which is transform 2, is going to be this block here. That's going to be, of course, divided into 28, 28. So the input of the next transform will be C1, D1, and so on and so forth. So every time you get a transform, the input is at 56 block bit divided into left and right of 28 bits, and the output is of that one is gonna be a key. That's the one that we're looking for, and it also outputs another block for the next transform. Of course, the last transform 16, is not gonna have any block output. Is going to have only the key output, because that's where we are interested in the keys, so sub-keys in this case. So as I mentioned, the LS1 is a left shift, and it's a cyclic shift of 1 bit. Now in this case, I want you to be careful because not all the shifts are 1 bit. There are some shifts that are 2 bits, and I'll explain that in a second. But the first left shift, the one that we are doing here for this 28-bit, this is a 1-bit shift and a cyclic. So it's a left shift cyclically by 1 bit. So what do I mean by that, by left shift cyclic? So let me give you an example. So some of you might know what this already is, because many programming languages will have this kind of operation, left shift, but it's cyclic. Okay, so let's look at this example here. Suppose I have this, this is the 28 bit block, and the reason I'm doing a 28 is because these left shifts that are here, the left shifts are acting on 28-bit blocks. They don't act on the whole block, they just act on the 28-bit block. Now I suggest that you actually copy this table here, because it's going to help you understand what the transforms are. So if you want to pause the video and copy all this, that would be a good idea. Now, so let me go ahead and explain what that left shift is. So let's go ahead and do that. So again, so it's going to act on 28-bit. So I have my 28 bits right here. There are 28. If you don't believe me, you can pause the video and count all of those bits there. So it's 28 of them. And the left shift, which is a shift of only 1 bit, is going to do a left shift cyclically. What do I mean by that? So what I mean by that is this. You're going to look at the last, or depending on how you look at it, at this bit here. And you're going to move it to the beginning. So you're going to move it to here, to that part. Okay. And that will be the left shift. So if I actually do it here, if I do that transformation, so that 0 will go at the end. So let me write down that 0 at the end. So the 0 will be here at the end. And the rest of this here, the rest all of it will go right after this guy. So you only take, let me say that again. So you take the last, or the first one, however you want to look at it, this bit that is here, you move it here, and you leave the other bits exactly the same thing. So take it here, move it to the beginning. Now what I'm going to do here is I'm going to try to copy and paste this, because I don't want to write actually all those down. So I'm going to delete that arrow, as you imagine exactly what we did there. So we moved the 0 at the end. Okay. And I'm going to copy and paste that. So let's see that. So I'm going to copy this part, this last part, because except for the 0. I'm going to copy this, and I'm going to paste it over here. All right. So once I've done that, this is the output of the left shift. Again, what we did was we moved the 0 that was here to this position, and the other positions are left unchanged. Oops, let me delete that. The other positions are left unchanged over here. So that's a left shift cyclically of 1 bit. So that's what the left shift is doing. So, and that is, left shift is acting on the 28 blocks, 28-bit block. That is this one, Z0. It does that for that block, and it's that exactly the same thing for this other block over here. And that's what comes out of here. The C1 will be, for example, if this guy here were Z0, then this guy over here will be Z1. So that's what is doing this part here. So the left shift is shifting cyclically those 28 bits, and of course you get a 28 bit again, because we are not changing the number of bits. So that's how we get this block here. Now this block, because this is transform 1, is going to be the input of the next transform. And the next transform is going to do something similar to this one. Now, how do we get the key out of this? So the key out of this is, once you're done with the shift here, with this block, we're going to apply a permutation to this 56 block that is here. So now don't imagine that they are divided. This is only one single block of 56, and I'm going to apply this permutation that we call permutation PC2. So let's see how that is. So now this one again is gonna be a table. So if we go, let me scroll all the way down here. So that is the PC2. So PC2 is a table, and it tells me how to transform the 56 bits into the 48 bits. And this is gonna ignore some 8 bits from the 56 bits. So as always, this permutation, you read it as we read all the other permutations. So if you look at 14 here, what that means is the bit in position 14 will be transformed into position 1, and then similarly 17. So the bit in position 17 will be transformed into 2, and so on and so forward. So this PC2 is going to act again on a 56 bit, and it's going to give me a 48 bit. So let's see a little bit of example here for it. So let's say I have my 56 bit block here, and I'm going to transform it with the PC2 into this 48 bit that is right here. So let's say, for example, let's look at the for example of this operation here. 14 goes to 1. So what that means is whatever is in position 14 of this block, so let's say is over here. So for example, this is position 14, and again, this is not a scale. So let's say this is 14. Whatever bit is in there, in that position, will go to position 1. So if I mark this with an arrow, let's do this, it will go to position 1. So for example, if there is a 0 there, so let's say there is a 0 there, then that will go 0 here. Okay, and similarly with the other one. So if I have 17, the 17 will go into position 2. So 17 somewhere, let's say over here, I have 17 very close to 14. Again, this is not a scale, and so if this is 17, then whatever bit is in there will have to go to position 2 in the 48 bit. So we'll go there. So for example, if that is a 1, then this will have to go into a 1. So that's what the block of the 48 bit will be. And this guy right here, that's the important part. This will be the first sub key. So let's mark that down. That's important. So that will be the first sub key. That's the key that is being put in the round 1. So basically what it in a sense, what it's gonna do is gonna go into the f function of the round 1, if you remember that from the previous videos. So that's how this transform is gonna work here. So let me go back here to the picture. Let's look at the picture again. So let's review it one more time. So the transform 1 is gonna take a block of 56 bits, left and right. It's gonna do a left shift of 1 bit only for the left hand side, and I get C1, which is the block 28 after I shift 1 bit to the left. And the similar thing, I have the right hand side that I call D0. I do a left shift, and then I get D1. That's my 56 block. At the end here, I apply the permutation PC2, the one we just saw, and then I get out my 48-bit block, which is the subkey K1 that will go, of course, into the round 1 of the DES. Now, I told you that we have to be careful here because some of the shifts are 2 bits, are 1 bit or 2 bits. Now, the transform 1 is going to do the 1 bit shift. So let me scroll all the way down again, and let me emphasize that. So let's say that I'm gonna be here very specific on which ones are 1 bit and which ones are 2 bits. So left shifts are 1 or 2 bits for all the transform, and it depends on the transform. So 1 bit is for transforms 1, 2, 9, and 16. So transform 1 is 1 bit, the one we just saw. Transform 2 will be also 1 bit. But transform 3 is gonna be 2 bits because 2 bits are for the rest of the transform. So transform 3 will be 2 bits. Transform 4 will be 2 bits. Transform 5 will be 2 bits. Transform 6 will be 2 bits, and so on. The only ones that are 1 bit is transform 1, transform 2, transform 9, and transform 16. And that's very important because not all of them are 1 bit. Now, for example, if we look at the picture of transform 1, which is very similar to the picture of transform 2, the input of that transform, of course, will be C1, D1, which is this. Remember, this was the output of transform 1. And it's going to do exactly the same thing. It's already divided into 2 blocks. I do a left shift of only 1 bit because transform 2 is what they transform, one of the transforms that's only 1 bit left shift. And then I do the same thing, so I get a block of 56 bits after that shift for the individual blocks. I get my 56 block, and I do again the same transformation PC to, transformation but permutation of PC2 here to get my 48 block bit, and of course that's going to be the subkey number 2. Now, as I mentioned, this LS2 is a left shift cyclically 1 bit, but in transform 3, that's the first transform that's a 2-bit left shift. So the LS3 will be a left shift cyclically 2 bits. Okay, so let me actually do an example here to emphasize what I'm doing. So we're gonna do a left shift cyclically 2 bits here. So what's gonna happen is you're gonna do a shift of 2 bits, so you do it 1 by 1. So we're gonna move, for example, let's say, let me use a color here. So I'm gonna use 0, and I'm gonna move it there, and I take a 1 and move it right behind that 0. So what do I mean by that? So let me just erase that arrow again to be more specific here. So I'm gonna take that 0 that is here. Let me mark that down with color. This 0. I'm gonna move it over here. So let me move it here. So that's gonna be the 0. Then I take the next one because this is a 2-bit left shift. So I take the next guy here. So let's use this color. This 1 is that bit, and then I'm gonna move it right over here. Okay, that behind that 0. All right. So once that's done, then you see I have here this block here that I don't touch. I just take all this here and I copy all this, what is here, right after this 0, 1. So let me do the same as I did before with the examples. I'm going to try to copy and paste this. So I'm going to copy this whole thing here, copy it, and I'm going to put it right here, right where that belongs. All right. So basically what we are doing is if you shift 2 bits, what you're basically doing is doing 1 bit and then 1 bit again. So you move again, you take the 0, you move it at here, and then you take the 1 and you move it right behind that 0 over there. And so that, of course, this is gonna give me, of course, a 28 bit again. So that's what the left shift in the transformer 3 is gonna do. And those 2-bit transformations are gonna happen for, let me go back again to emphasize that because it's important, is gonna happen for transformations that are not 1, 2, 9, and 16. So 1, 2, 9, and 16 are the only transformations that are for 1 bit. And for the 2 bits are for the other ones, for transformations 3, 4, 5, 6, and so on, with whatever is not in here. Now, so actually with this, we actually finally describe all the key schedule. Of course, there are 16 transformations. All of them have this inner structure. The only difference between them is that some of them are 1 bit left shift and some others are 2 bits. So that completely describes now how the DES works. Now in the next video, what we're gonna do is we're gonna discuss how do we do the decryption, because all what we are doing here is encryption. So this is the encryption. You take a plain text, put it in DES, you put the key and the key K, which is you have to do a key schedule, put it in the rounds, and then out of it, what you get is ciphertext. Now, what happens when you want to do the decryption? When you get the ciphertext, and then you want to get the plain text from it. So that we'll discuss that a specific step in the next video, and it's not gonna take a very long time, because basically what's gonna be is just we're gonna reverse the key schedule, and that's all we have to do. So I'll see you in the next video.